Hello and welcome to the CET's Data Space workshop, No-Code Data Acquisition and Visualization with Pyrus. The knowledge acquired here can be used, among other things, to develop data-driven business models. For this purpose, basic methods of data acquisition are first shown and explained, which are the prerequisite for data processing. Subsequently, it will be shown how the collected data can be visualized in different ways. This workshop is primarily intended for people who have no knowledge of programming. For the use of the dataspace Pyrus and JupyterHub accounts are required, which can be requested from the CET staff. Within this workshop, the initial steps to log into JupyterHub and Pyrus and how the user interface is structured will be explained. JupyterHub is used as a powerful execution environment which can be controlled via Pyrus without code. For this purpose, we will first show how the JupyterHub and Pyrus can be linked, followed by several examples of data collection from different sources. Finally, various methods of data visualization will be demonstrated. It should be said at the outset that all examples used here are intended only to give an introduction to the subject and only scratch the surface of what is possible. Pyrus is a flexible execution environment that can handle a wide variety of problems and can be extended by any user. The first step before using Pyrus and JupyterHub is to apply for access. Just send an informal mail to Philipp Zweihoff, who will set up the account and send back a username. At the first login, this username has to be entered with a password, which registers the access in the system. The password will be determined at the first login. After clicking on Login, the README will be opened, which is not relevant for this workshop yet. To link the Pyrus, a key must be created by first pressing the Control Panel button in the upper right corner. After that, you will find the menu Item Token in the upper left corner, which opens the key management by clicking on it. In the key management, keys can be created and revoked. For a better overview, the keys should be named, e.g. here with Pyro. With a click on Request New API Token, the key is requested and then displayed. This key should be saved or noted in a safe place, because it cannot be viewed afterwards. Now the login in Pyrus takes place, which also requires a request. The returned username must be entered into the username field of the registration mask. All other fields can be filled in freely. After clicking Register, the account will be activated and you can log in on the login page. The first view shows the organization management of Pyrus. In Pyrus, users can participate in several different organizations to collaborate with others. After the first login, the user only has his own organization and does not participate in any other, so the list hosts only one entry. To log out of the system or edit one's profile, the menu items in the upper right corner can be used. First, a click on the organization leads to the next view of the individual organization. An organization has different management options. First, an organization can contain and manage multiple projects with specific access rights for the users within the organization. In addition to the projects, the participating users can be managed, as well as their rights within the organization management. However, these options are not important for this workshop. As you can see, an initial project has already been created, which can be opened by clicking on the name. The next step shows the editor of Pyrus, which is divided into different areas. At the top is the navigation menu to jump back to one of the previous views or to manage the areas and services. Under the navigation on the left is the Explorer, which shows and manages the file system of the current project. A machine learning model offers the possibility to graphically create and execute data flow processes. The canvas in the center of the editor shows the currently empty model. The model corresponding to a file is also displayed in the Project Explorer. On the right side is the palette of usable components and below the validation. The validation shows at any time whether the model is executable and at which places still problems exist. Now the connection to the JupyterHub should be established. To do this, click on Connect Jupyter Account in the navigation menu under Service. The subsequently opened form must be filled out with the previously noted key and Jupyter username. After clicking Submit, a few seconds later a message should appear that the connection has been successfully established. Now that the connection is established, the functions of the JupyterHub can be loaded. To do this, click on Synchronize Functions again via Service. This process can take up to 20 seconds until the green message appears at the top of the screen. Afterwards, the loaded functions can be loaded and displayed in the eCore area at the bottom left. These functions can be used to create data processing procedures. Now that the basics of Pyro usage are clear, the data processing topics can be tackled, starting with acquisition. This is done by first showing how to upload and download CSV files. Then the actual data from the files will be loaded and displayed. First, a CSV file is to be uploaded from your own computer to Pyro. To do this, a sample CSV file can be downloaded using the short link provided here. To upload a file, right-click on the project name in the Explorer. In the menu that appears, click on New and then select Binary in the dialog. Now there is a Select File button at the bottom, which opens the file browser of your computer. Afterwards, the previously downloaded username.csv file should be selected and the upload confirmed. At this point, it should be made clear that the file is always uploaded to the directory of the project selected with the right click. Now the data can be read from the file. For this, the Load CSV function in the Table Util folder is selected. To use the function, simply drag it onto the canvas, whereupon the function is inserted with suitable data inputs and outputs. As you can see, the inputs are visualized with a yellow arrow on the left side and the outputs with a blue arrow on the right side. Also, you see that the validation marks the inputs and outputs in red, because here is not clear where the data comes from and where it should flow to. To define static data, the palette on the right offers several constants. To include the username.csv file, a file path constant is needed, which can be dragged from the palette to the canvas. Then a text constant for the separator must be inserted following the same procedure. The values of the two constants can be set using the area below the canvas. To do this, select the appropriate constant and enter the file name username.csv and the separator semicolon in the form that appears. Afterwards, the data flow can be modeled. To do this, first select a constant with a click. Now the black circle can be pressed and held to draw an edge to the respective input. By releasing the mouse over the corresponding input, the edge is created. Since the data from the table can now be loaded, it only needs to be visualized. For this, the print table function from the Table Util folder can be used. This is also dragged from the eCore area onto the canvas. As can be seen, the function expects a table at its input. This table returns the load CSV function, whose output only has to be connected to the input of the print table function. At this point, the validation should show no more errors and the model can be executed. To do this, right-click on an empty area of the canvas. In the menu that appears, click on Execute on Jupyter. This process may take a few seconds until the result is displayed. Finally, the results can be discarded, saved locally on the computer or in Pyrus. Now that it's clear how data is collected, the visualization can be explained next. For this purpose, it is shown how loaded data is visualized as a table, points and curve in a graph. The first example shows, as seen before, a process to load and visualize data. However, this time a CSV file is to be loaded from the JupyterHub. Therefore, the previous file path constant must be deleted via the red X and replaced with a text constant. The value of the constant should be set to example_data/2d.csv. The JupyterHub provides several examples to illustrate the workshops. All data can be viewed in the file system of the JupyterHub. Besides the path to the file, also the separator has to be adjusted. For this, the value of the other text constant is set to comma. Finally, the process is executed again via right-click Execute on Jupyter. The result shows the data of the 2d.csv file. The second example shows the visualization of the data as points in a graph. For this, the function scatter from the table2d folder is used, which expects a 2D table because only points in two-dimensional space can be displayed. The reduction of a general table to a two-dimensional one is done by the select2dTable function, which expects a table and two column names. The two column names are defined by text constant elements and connected to the inputs. After the rest of the data flow have been drawn, the model can be executed and will display the points of the 2d.csv in the graph. The last example shows the visualization of the collected data as a curve. To do this, simply replace the scatter method with plot. After execution, the graph should now display a function curve. I hope you were able to follow all the examples and get an insight into the use of Pyrus. It was shown how Pyrus can be used to collect data in the form of CSV files. Files from both local and global sources were used. Afterwards, different visualization forms for data were demonstrated. Of course, this workshop only gives a first introduction into the complex matter, but the shown mechanisms should be enough to achieve first successes for your project. Furthermore, the workshop provides the basics for the next workshop onto no-code data analysis, machine learning and artificial intelligence. Thanks for participating, and I hope to see you soon in the data space of the CET.